right. Welcome. Steve in the house. And Felix, thanks for joining. I got my code book just in case I want to use it. Ooh, so today's topic for IAI News Live. Hey, Felix, I got my Colombian roast, buddy. Gotta have it. So, or this could be Costa Rican. I don't know. I've got mix back there, so I don't know if I made Costa Rica coffee or if I made Colombian. They're both good. Anyway, all right. So, okay. The title of this one is The Unprotected Conductor. And Steve, you know where I got the idea for this one, because I was thinking about all of the different areas in the code where we have conductors that are not protected. And in my extra salute Felix, yes, in your extra special mug, it does taste a lot better. In fact, I gotta get out my Shock Week mug, and we're coming up with another Shock Week here at the end of May. So so what I thought of was, I had this discussion a little bit ago about unprotected conductors, which we focused on the secondary of a transformer in our discussions. But there are other places within the National Electrical Code that have unprotected conductors, and I'd love to take a look at all those different areas and see how they are handled. Mr. Hofken in the house, thanks for joining us. So I'd love to take a look at all of the different areas within the National Electrical Code where we have unprotected conductors, then how do we address them? So there's more than, and we have our research, the research department is in the house. Laurel, thank you for joining us. We would not be able to start without you. So I was basically delaying everything just until Laurel showed up. So thanks for showing up. So what I'd love to do is take a look and think about where are the unprotected conductors? And what do we mean by that? So the most obvious location, I've got to get to NFPA link. So I got to bring up NFPA link. I'm going to put it over here. So I got NFPA link over here and over there. And on, I need to bring up, I have desktop. I threw some photos in an unprotected, what do you call it? Folder on my computer. And let me do this as a gallery. Here's so another one of the most obvious, I would argue, one of the most obvious locations for, how do I do this? I want to get rid of this on the side. There we go. One of the most obvious locations for unprotected conductors is right here. So I've got a service type of equipment where I'm coming from a utility and I'm coming directly in, and so right in here, in this area right here is where my meter socket would typically be. The conductors that come in here are unprotected conductors from the utility. I hit the meter socket, still unprotected. Meter socket, still unprotected. from short circuits, right? So I would arguably have overload protection for those conductors just because of overloads all stay in the circuit. So I could have overload protection just because I am in series with an overcurrent protected device. In this case, I believe those are 2 circuit breakers. So those conductors are not protected from short circuits, but they are protected from overloads. But they're unprotected conductors, and we have rules in Article 230 that specifically help us address what do we do with unprotected conductors. That's just one source of power. And who do we got? Who just came on? I'm blindly hitting things. Oh, Robert from Omaha. Excellent. Had to walk my emotional support dog. Oh, excellent. You know, I was just going to tell you, boy, somebody sent me a joke about an emotional support dog, and it was you. Anyway, oh my goodness, Laurel, you got your hands full with this guy. I'm telling you, in that state. So here's another good picture. Took this one down in Alabama. This is what I liked about this photo was the transformer. The utility transformer is right there outside of that piece of equipment, and the available fault currents are going to be higher. The conductors that are in that raceway that are coming from the transformer. We have rules in Article 230 specifically that address the protection of service entrance conductors. And if you look to Article 230, the same for overhead. Oh yeah, absolutely. Overhead conductors, underground service conductors, service laterals. There's a host of service equipment that is basically unprotected, right? So we get it. We understand the fact that we have these conductors, and what do? So if you think about overhead conductors, Robert, we have rules in the code that basically we know we're not protecting them from an overcurrent, but what do? How do we protect ourselves? We keep distances. Right? We have distance requirements from windows. We have distance requirement from platforms, distance requirement from over a roof, and also distance requirements when we're over a swimming pool, things like that, right? So we have these requirements and restrictions where you can't do certain things with these conductors. Can't run them through a building, through a structure. We have rules in Article 230 that tell us I can't run these through a structure. In fact, Robert, in fact, service entrance conductors, if I'm not mistaken, boom, 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 we have 230.50, which talks about protection against physical damage. So we physically protect. And I wouldn't say, are we protecting the conductors? Or are we protecting ourselves, right? But we're doing a little bit of both. If I can protect those conductors from damage and harm physically, then I am avoiding and getting rid of the, not getting rid of, I'm reducing the likelihood. I gotta be careful, but of causing a fault of some sort, right? So we have 230.50 that gives us protection against physical damage. We have 230.51 that tells us how to mount and how to secure these conductors. 230.52 tells us individual conductors entering buildings or other structures. It says where individual open conductors enter a building or other structure, they have to enter through a roof bushings or through the wall in an upward slant. Through individual non-combustible, non-absorbent insulating tubes, drip loops shall be formed on the conductors before they enter the tubes, right? So we have specific requirements for these unprotected conductors. Now, we also have in 230. I think it's 70. Let's go to 230.70. PV. Oh yes, 230.70 means shall be provided to disconnect all ungrounded conductors in buildings or other structures from service conductors. So I know I have to have a disconnecting means to disconnect from those service entrance conductors. The service disconnecting means has to be installed at a readily accessible either outside of a building or structure or inside nearest the point of entrance of the service conductors. So if I am entering a structure with these service conductors, these are unprotected conductors, we deal with them specially and we say, look, if you're going to enter a structure with these unprotected conductors, you have to terminate on an overcurrent device at the nearest point of entrance. We don't have distances. We don't have lengths of conductors, unprotected conductors that are permitted inside of a structure. We don't have that in 230.70 to my knowledge. And I know that those have been proposed in the past. Now, Felix, you bring up another very valid point. What about these? What about these? I have photovoltaic systems. These are unprotected conductors. They're coming straight off of the PV panel, right? I'm coming straight off the PV panel, and there's no, now that little blob right here, this little guy right there, is not a fuse, right? That's just a connection, and it's not listed as a. I believe those specifically say do not disconnect under load. They're not a disconnect. They're not listed as a disconnect. So, but in any case, these are sources, and those conductors are unprotected. Now, I would think that I would go to Article 690, right? We would go to 690, and we should, for solar photovoltaic systems, we have some good diagrams in here that basically help us understand the terminology, right? So I know I have PV string circuits or PV source circuits. So for the proper application of those PV source circuits, which we know are non-protected or unprotected conductors, I'm going to have specific rules in the National Electrical Code. And what we would do then is we would go into 690 and we would look for the rules for PV source circuits. So we could go into, what do you call it? NFPA link, right? Love the program, love the software, and I would search for, what would I search for? PV source circuits. Geez, I was trying to think of the name. I just said it. So photovoltaic source circuits, 690.6, 690.7, bipolar PV source circuits, 690.7, and it says the requirements 690 pertain shall not apply to AC modules or AC module systems. The maximum DC voltage shall be calculated. Maximum voltage. So what I'm looking for, we have sizing requirements. Hey, dobro dan, Kakos TV. Marking and labeling requirements. So we've got awareness. We're driving awareness through marking. Overcurrent devices used in PV source circuits shall be listed for those applications. 690.1 system calculating PV source maximum circuit currents. So remember, one of the things that we do, look at this. So one of the things that we do, if you recall, in PV systems, we'll take these circuits, these conductors, and we size them well beyond a normal overload, right? One of the biggest violations, aside from improper grounding and bonding, is customer-owned transformers to main lug and or inadequate OCPDs and conductors inadequate ampacities. I agree with you 100%, Steve. I agree with you 100%. Now, what we do when we think about the conductors in a PV system, these are unprotected conductors. You have the source right there. There's no overcurrent protection at the source. So we talk about special listings, right? How do I do this? I'm going into, oh boy, 690.31, I think it is. Take a look at 690.31. It's called wiring methods in the National Electrical Code. 690.31 has wiring systems, requirements, and ampacity values, identification and grouping. And then when you get down to cables, PV wire or cable and type distribution generator cable shall be listed, right? It says single conductor cables in exposed outdoor locations in PV system DC circuits. Oh, by the way, I do believe that's what this is, right? That's, in my opinion, these are unprotected conductors. These are single conductor cables in exposed outdoor locations, all right? Within the PV array shall be permitted to be one of the following: PV wire or cable, single conductor cable marked sunlight resistant, and type USE2 and type RHW2. They have to be supported and secured at intervals not exceeding 24 inches by cable ties, straps, hangers, or similar fittings. Exposed cables size larger than number 8 shall be supported and secured. So what we're doing in the code for these unprotected conductors, and what you're going to see are special provisions. Now these are outdoors, where direct current circuits in or on a building. All right. So now, so it's, man, I'm getting excited here. You'll recognize in the code that we treat conductors one way when they're outside. And in fact, in a PV system, we'll do special things when the PV system is out in the field, right? But the moment that we have these unprotected conductors entering a structure, we get focused on providing certain levels of physical protection. Marking, we want to know those conductors are there. We want to know what they are, where they are. Now, in a PV system, wiring methods on or in buildings is covered in 690.31D as in David, where inside buildings, PV system DC circuits that exceed 30 volts or 8 amps have to be contained in metal raceways, in type MC metal-clad cable that complies with 250, 118, A10B, or A10C, or in metal enclosures. Hey, Joseph Violi, there he is. The man, the legend. Now we can get started. So we're taking special provisions for providing protection of these conductors. Right here, it says it, where inside buildings, 8 amps. So we're giving you that exceed 30 volts. So if it's less than 30 volts or less than 8 amps, they have to be contained in metal, or if it's greater than, if it exceeds 30 volts. If it's less than, then I don't have to worry about these. There is an exception for non-metallic, but you're still enclosing them. So what we're doing is we're physically protecting these. We're also marking these these applications or these conductors and raceways. We want to raise awareness that we have these unprotected conductors inside of a structure. And then we say, look, I don't care, but if you have equipment that's over 1,000 volts DC, shall not be permitted on or in a 1 and 2 family dwelling unit, cannot be permitted within buildings containing habitable rooms, where installed on the exterior of buildings. Wiring methods containing DC circuits connected to this system shall not be permitted to attach to the building greater than 33 feet along the building surface of the equipment. So we're taking special care, right? So that's PV systems. Where else? What other system? How about this? How about this? Huh? Look at these. These are batteries. Those conductors coming off of that battery are not protected right at its source. Look at that. That is a conductor coming off of a battery. It's before the overcurrent protective device. These conductors are not protected. If I have a fault of some nature on those conductors for whatever reason, I don't have a disconnect. I don't have an ability to stop that battery from providing energy to those conductors. So now where would I go? Right? Where would you go for the Paul? What's Paul? Do I see Paul? Paul Bunbury, good morning. Paul, good to see you. Thanks for joining us. We wouldn't have started without you, brother. So where would you go for the rules for these conductors? Where would you go in the National Electrical Code to understand the rules around those battery terminals and the conductors that are connected to them? Since it is a battery, where would I go? Battery. Is that equipment for general use? Would you consider a battery? There we go. Equipment for general use. Article 480, stationary standby batteries is probably where you would want to go. Equipment, storage batteries, and battery management equipment shall be listed. So all of that has to be listed. Battery cell terminations, where mating dissimilar metals, antioxidant materials suitable for battery connections shall be used where recommended by the battery manufacturers. They have intercell and interior. There's my buddy. Come on, Jake. Yep, it's my buddy. So the ampacity of field. Look at this. Wait, hold on. Watch this. Camera A. What does this say? Intercell. The ampacity of field assembled intercell and interior connectors and conductors shall be of such cross-sectional area that the temperature rise under maximum load conditions and maximum ambient temperature shall not exceed the safe operation temperature of the conductor insulation. So we're worried about the conductors. We have the battery terminals, electrical connections to batteries and cables between cells shall not put mechanical strain on the battery terminals. So we're worried about physical protection when we're dealing with these connection points. We've got to think about the physical terminations. We don't want to put any strain on those. Why? Because that's a failure point. That would be ungood, right? So accessibility, the terminals of all cells or multi-cell units shall be readily accessible for readings, inspections, and cleaning where required. There's a tie to 70B. It has to be readily accessible for inspection and cleaning. So I have unprotected conductors. Now if I look at this, I'm not putting it in a raceway. Now I would argue and I could probably successfully argue that, trying to see, well, these are batteries here too, right? But now they're all in an enclosure. These are, I think those are super caps, if I'm not mistaken. What's a super cap? Go boy, he's up on the couch. He's up on the couch. These are your 62 volt DC. These are supercapacitors that's a close up of what I just saw in one of these photos here. And a supercapacitor basically gives me the ability to provide power for a shorter duration. I'm not going to run off of a super cap for hours. I'm going to use that as a ride through, and that's why you'll see them in data center applications where you need power for that short time transition when you're going from one source maybe to another. We have to have zero interruption. Okay, so the NEC recognizes multiple sources. Where's another source? So we went over photovoltaic. We talked about supercapacitors. We talked about batteries. Oh, here's a good picture. This one. This is an image of the wiring diagram for those batteries. So it's a 480 volt DC battery cabinet. You have these are your conductors, and you'll notice how these batteries are in series. And when we add batteries in series like this, we are increasing the voltage. If I put them in parallel, I'm increasing the amperage. Okay, so each of those batteries are connected in series, and then they're connected up through a circuit breaker, right? So you got both sides, and they're using, this one's using 2 poles. Boy, there's your plus out and your minus out. So there's your plus. That's coming from the battery. That's coming up through 2 poles and coming down. This, I'm just trying to, oh, okay, all of these are in series. All right, now I see the diagram now. All right, so you'll notice I have, if I bring this down, that goes out. This is in. That line comes over all the way down, back up, and through here. So I'm taking the negative. I'm taking one lead through 2 poles, the other lead through 1 pole, divide and conquer, basically. So, but I do have a circuit breaker. So coming out of this enclosure, I have protection for the external conductors, but in the enclosure, I have basically I've contained all those conductors in a listed assembly and providing protection through other means that are governed by the UL standards, right? So internal to the equipment, we'll do certain things from a configuration of the equipment, and the UL standards help ensure the product has that level of protection that's required. 706. Oh, Article 706. Right. So 480 is batteries, but to your point, Robert, Article 706 will be your energy storage systems. Where's 706? Energy storage systems talk about the required for a. They'll say that the energy storage system has to be listed as an energy storage system. You have a disconnecting means required. And it says, oh, I love this. The disconnecting means shall be readily accessible and shall comply with one or more. Located within the energy storage system, located within sight of, that's within from 10 foot from the energy storage system. Where not located within sight of the ESS, the disconnecting means or the enclosure providing, and I'm reading from 706.15b, as in Bob, shall be capable of being locked in accordance with 110. Where controls to activate the disconnecting means, all right, notification of marking, but what I'm looking for, we have ventilation requirements, we have directories, we have circuit sizing, maximum rated conductor ampacity, protection devices for energy storage system circuits shall be in accordance with 706.31b through F. Circuits have to be protected at the source from overcurrent. So this is saying, Robert, that the protection devices, right? So if I look at this, this is in A. This is 706.31a. Protection devices for energy storage system circuits have to be in accordance with 706.31b through F. Circuits shall be protected at the source from overcurrent. A circuit conductor connected at one end to supply with integral fault protection, where the conductor is rated for the maximum circuit current from that supply and is also connected to sources having an available maximum circuit current greater than the ampacity of the conductor, shall be protected from overcurrent at the point of connection to the higher current source. So, I love this stuff. So what do we know? We know that we have unprotected conductors. We have unprotected conductors that come from the battery terminals. We have unprotected conductors that come from a photovoltaic panel. And if I put those all in series, even the batteries, if I put those in series, I'm increasing the voltage. Then if I put parallel, now I'm increasing the amperage, which increases the available fault currents and all that jazz. We know that if in case of a battery, I'm going to go to chapter 4. In the case of an energy storage system, I'm going to chapter 7. In the case of services, I'm going to chapter 2, article 230. Oh, one other very important part of the puzzle. Hold on. Let me go to my pictures, and I'm going to do a Control F for find, and I'm going to search for that. I'm not telling you. How about, I was on an inspection one time. Well, not just one time. I've been on inspections, and we were looking at this puppy. This is before we opened the equipment up. There it is. We were looking at one of these puppies. All right. Man, oh day, I tell you. There it is. So we had a generator. The leads that come off of the generator itself before it hits an overcurrent protected device are unprotected conductors. Would you not agree with that? I would hope you would agree. we got into that puppy, and what I noticed there was we have a generator source, but we're also down here in the corner there was a battery, right? So in this case, I had a battery with unprotected conductors coming from the leads. I have a generator, which is putting power out, and then that's going to go to an overcurrent device, and that length of conductor from the terminals of the generator to that overcurrent device are unprotected conductors. And where do I go for generators? Where do we go for generators? Chapter 4, right? Because chapter 4 is your equipment for general use, and I would go to 430 for motors and motor circuits. I would go to 445 for generators, right? So it tells you stationary generators have to be listed. There's marking requirements. There's overcurrent protection. Where the generator set is equipped with a listed overcurrent protected device. They give you the ampacity of the conductors from the generator output terminals. Here we go. Look at this. Look at this. 445.13 deals with the ampacity of those conductors. The ampacity of the conductors from the generator output terminals to the first distribution devices containing overcurrent protection shall not be less than 115% of the nameplate rating. It shall be permitted to size the neutral conductors, but it doesn't talk about, it doesn't give us rules if those conductors leave the enclosure, or does it? Generators, there's a disconnecting means. Generators other than cord and plug connected pair, but you know what? You probably would go to the product standard to find when you have that overcurrent protective device in the rules with regard to protecting those conductors inside, because they're required to be listed. It says, so I have, then we have transformers. So we've got generators, we have photovoltaic systems, we have batteries, we have energy storage systems, and now we're going to have transformers as well. Now, transformers, I have a diagram, not had. I have a diagram. Yes, generators in 445. So I have a diagram that I was looking at the other day. And how do I open Sesame? Whoops, I don't want that. I want transformer secondary conductors. All right, so I have conductors at the secondary of a transformer, which I thought I had a good photo, but I don't know that I do. Let's talk about service. Your typical service installation. All right. Whoop, I gotta maximize this. So in a service, you're going to have a utility transformer. You'll have the service conductors. We'll have rules for protection of those service conductors. If they enter a building, they have to land on a service disconnecting means within at nearest point of entry of the service conductors to the structure. We have rules when you're putting what you can place within those service conductors. We have rules, specific rules for placement of things like power distribution blocks or current limiters, cable limiters, not current limiters, cable limiters. 23082, is it 23082, Robert? 23082, yes. It tells you what can be placed on the line side of these, on the supply side of the service disconnecting means. You have your meter sockets that are permitted there, your cable limiters that are permitted there, power distribution blocks. But power distribution blocks is not in 23082. We fixed that in the 2026 code cycle. But we have permissions, and we do have the provisions within Article 230 for placement of those power distribution blocks. 230.46, spliced and tapped conductors. 230.40 tells us that we can splice and tap these unprotected conductors, but my point is that we have specific rules for unprotected conductors inside when they're service equipment. And also, I would ask the question of whether or not we've got to think about those conductors just from a secondary of the transformer. If I'm looking at those transformer secondary conductors, I have unprotected conductors there as well. In Article 230 or Article 240, I wouldn't go to 230 for just any transformer. 240 location in circuit. The location in circuit is 240.21. That's where we get to the you got your tap feeder taps. Tap conductors are unprotected conductors, right? So from a short circuit perspective, so we have let's just list these things out. Let me bring up a slide deck. I want to keep track of the unprotected conductors that we've talked about thus far. Layout, blank. I want to go to layout, blank, delete. All right. Format background. And we'll give it a black background. We're going to put our text in here. And we're going to make the text white. And we're going to make it large. Meanwhile, Tommy, see calibration. There we go. All right. Okay, here we go. Let's, boom, let's do this. You ready for this? All right. So, we know we have service conductors. We've talked about service conductors. We've talked about generator output conductors, battery output conductors, energy storage system output conductors. Is that accurate? An energy storage system is a listed product. I believe the output of those energy storage systems are protected conductors. How about generator battery? PV source circuits. Ooh, I love it. Transformer secondary conductors. This is, we'll say, three-phase, non-delta delta, or single phase. Solar PV, yes, solar. Photovoltaic source circuits, transformer secondary conductors, generator output conductors. Now, what about, let me ask you a question. What about the appliance cords? How about the cord that is on a toaster? Or the cord, the toaster cord's a good example because we know that conductor is not the same size as the 15 or 20 amp circuit to which it's plugged into. Oh, taps. Taps. Yes, tap conductors. Tap conductors. So we know, what about, Felix? What about these, appliances? What about those? Now, Article 240. Now that's a load. That's not a source. So when I'm thinking about loads now, right? Everything that we've had here, everything that we've had in here are true sources, right? My service, that's coming from the utility. My generator output conductor, that's a rotating, that's generating voltage, it's generating current. Batteries, I may not be generating, but I'm discharging stored energy. My PV source, I'm generating it from the sun. Transformer secondary conductors, those aren't, I'm not generating it, but they are unprotected conductors, and the power distribution system, as long as it is on, is delivering power through those conductors. Tap conductors, same way. But what about an appliance? It's a load. If I look at 240, Article 240, what does it tell us? Conductors. It says, other than flexible cords, flexible cables, and fixture wires shall be protected against overcurrent in accordance with their ampacities specified in 310.14. Why would you not have to protect flexible cords, flexible cables, and fixture wires? Where does the protection come from in those cases? Let's look. What do we got? Product safety standards cover the unit. So, Robert, if I have an appliance and I am consuming power, I know how much current I'm going to draw. If I have an attached cord to that appliance and I'm a listed product and I'm used within my rating, I'm the only load on that conductor. I can ensure that I am only going to draw so much current. Now, I don't necessarily have a overcurrent protected device at the beginning of that extension cord or at the beginning of the appliance at the beginning of the flexible cord that's going to that appliance. Let's do a quick search. Protection in 240.5. I love this. So, Felix, in 240.5, we have the title of 240.5 is Protection of Flexible Cords, Flexible Cables, and Fixture Wires. And it says flexible cord and cable shall be protected by an overcurrent device in accordance with their ampacity as specified in table 400.5A1 and 400.5A2. Fixture wire shall be protected against overcurrent in accordance with its ampacity. Supplementary overcurrent protection as covered in 240.10 shall be permitted to be an acceptable means for providing this protection. Supplementary protection. You may see that in an appliance. You may have a supplementary protection. Uh-oh. We've got David is in the house. Cords, cables, Article 400. We're going to get there. But 240 is my overcurrent protection. And I'm curious to see, what does it say in the National Electrical Code about protecting these conductors that are obviously way smaller than the branch circuit overcurrent protective device. And finally, we got David Engelhardt in the house. So David, what we're talking about now is protection of, we've come up with a list of all of these unprotected conductors that we'll find inside of a that are covered by the National Electrical Code and that we'll find inside of a power distribution system. These are all the sources, service conductors, generator output, all those good things. Now what we're doing is we are trying to say, let's take a look at some loads. I have an appliance that has a conductor, that has a cord and plug connected appliance. I'm going to plug it into a 15 or a 20 amp circuit, and that conductor is not rated for 15 or 20 amps. Article 240 tells me I need to protect all conductors. How am I protecting this appliance cord? In 240.5, we have a requirement for protection of flexible cords. We have the selection of the ampacity. We have the branch circuit overcurrent device. So flexible cords shall be protected where supplied by a branch circuit in accordance with one of the methods. So they give me different methods. Supply cord for a listed appliance where flexible cords or tinsel cord is approved for and used with a specific listed appliance or luminaire, it shall be considered to be protected when applied within the appliance or luminaire listing requirements. That is an important piece of the puzzle. When it comes to a load, like an appliance, a product, a motor, etc., I need to provide overcurrent protection. But when I have an appliance like a toaster, a microwave oven, my computer power supply, right? I'm considered protected when that product is applied within the listing and the instructions, basically, of that product. So if I took my toaster oven conductor and I pushed it through the wall and I popped it out and I plugged it in, I'm misapplying that product. Now I'm that conductor is designed to be in open air. It's not designed to be covered. It's not designed to be misapplied. So I've got to follow my instructions and understand the proper application of the appliance, because in 240.5, that conductor, that flexible cord or tinsel cord is considered to be protected because of how I'm applying it. So is it truly unprotected conductor? I could say I don't have physical protection of that conductor. And if I have arcing in it, what do we have? AFCIs. Arc fault circuit interrupters are there to provide the detection of those arcing and sparking and those faults inside of those connected cords and cables or tinsel cords. If it's a fixture wires are permitted to be tapped to the branch circuit conductor if a branch circuit in accordance with the following: 15 to 20 amp branch circuits, I can have up to 50 feet. Oh, look at this. I've got length restrictions again for fixture wires. Look at this. Fixture wires are permitted to be tapped to the branch circuit conductor of a branch circuit in accordance with the following. If it's a 15 or 20 amp branch circuit, I can have a number 18 up to 50 foot of run length. I can have a number 16 up to 100 feet. If it's a 20 amp branch circuit, 14 and larger, 12 and larger, 12 and larger. Extension cords, flexible cords and cables Flexible cord used in a listed extension cord set shall be considered to be protected when applied within the extension cord listing requirements. So, if I have an extension cord, I can't run it under carpets. I can't run it through walls, through insulation. I'm going to use it for temporary wiring or temporary power as it's intended to be used. I'm going to follow the manufacturer's instructions. And then I'm considered to be protected. And then anything I'm plugging into it. If I plug in a load that exceeds the ampere rating of the extension cord, I'm misapplying the extension cord. We expect those solutions to be applied within their ratings. Wooden appliance flexible cords, fixture cords become taps. Wait. Wooden appliances, flexible cords, and fixture cords become taps. Oh man, Felix. Here's my thought on that, Felix. I'm trying to think of how I would address that. Here's my thought. I don't think you're wrong. I don't think you're wrong. I think it would meet the definition of a tap conductor because it's not protected at its source. But I wouldn't go to 240.21 for tapped conductors and follow those rules when I have a section in 240.5 that says protection of flexible cords, flexible cables, and fixture wires. I have a specific section that addresses that application. That sort of trumps the 240.21 discussion. If I didn't have a 240.5 that dealt with protection of flexible cords, flexible cables, and fixture wires, then I would tend to agree with you that I would go back to the defined term of tap conductors, (240.4E1), 240.4E. Tap conductors shall be permitted to be protected against overcurrent. There we go. There you go. Oh man, Freddie B, with the UL listed toaster, who just went to his kitchen to find it. There it is, right there. Look at that. He pointed it out. 240.21E1. You have your household ranges and cooking appliances and other loads, but also, look, fixture wires, 240.5B2. So we got it covered. We definitely have got it covered. So, tap conductors, and Felix, very good observation. It's no different. It would meet the definition of a tap conductor, and we've addressed it in Article 240. So, my question is, for all of these unprotected conductors that we have in a power system, should we Steve. What's Steve saying? Maybe in a technical sense, Felix, but they are all part of listed assemblies with instructions, so they are expected to not be used outside of the instructions. Absolutely right. But, Steve, just as I think, who was it? Fred pointed out, 210.19C and D, household ranges and cooking appliances and other loads. 210.19C and D, if I go to 210.19C and D, 210.19C and D, 16. Oh, Hold on. 210. Wait a second. 210.19 C and D. I was looking at 240. Let's take a look at 210.19 C and D. 210.19 A, B, C, and D. Household ranges, branch circuit conductor supplying. That's the branch circuit. Hold on. Let's go back to 240. 240.4. 210.19C. 240.5B2 is fixture wires. 240.5B2. That's the length of conductors. Yeah. So I would still fall back on 240.5 for flexible cords and flexible cables. We use them. Steve, to your point, you're absolutely right. We use them. They are considered protected when they are a part of a listed assembly and they are used in accordance with their listing. That's the fact, Jack. Wow. We went through service conductors, generator output conductors, battery output conductors, PV source circuits, transformer secondary conductors, tap conductors. We talked about appliances and fixture wires and all of those that are technically smaller, not protected by the branch circuit overcurrent protected device. So we went through a lot this discussion in 1 hour. We covered a lot of material, and I hope that you got something out of this session. Thanks for joining in. Robert, what's Robert saying? Whoa. Robert is saying, agree they meet, Felix, but they have their own rules. Yep. And keep in mind, overcurrent protection covers short circuits, ground faults, absolutely right, and overloads in its various stages in the circuit. Absolutely. Most ranges I've hooked up are not factory cords. Oh, yeah, Fred, that's a good point. But, Fred, here's my thoughts on that. You would want to make sure that you are purchasing something that is identified for use with that appliance. The instructions should have information on what conductors to be used. All right, everybody. Thanks for joining in. I'm going to boogie. It's 1 o'clock. I'm 2 minutes late for another meeting. Thank you for a great dialogue. Thanks for what you do for the electrical industry. Thanks for what you do for electrical safety. Remember to stay safe. And please stay healthy. Felix, thank you very much, sir. Stay out of trouble. Catch you later. Next week is going to be a recorded session. I am not going to be available next week. I'm going to be in a different country. So I will have to record something. Maybe I can go live from France. I don't know. But I'm going to do what I can. Laurel, thank you. Take care, everybody. Stay safe. We're definitely going to have something next week. I'm just not sure what it's going to be. Thanks. Take care.